Hey everybody, welcome to lesson 6D, the quadratic formula, chapter 6.4 in the textbook. What is the quadratic formula? Well, first off, we recognize that the term quadratic is in here, which obviously defines all the functions and equations we've been working with. It represents the parabola. Now, but then, why do we need a formula for it? And what are we solving for? The x-intercept? The vertex? The y-intercept? Well, let's take a look at the formula itself to see if it gives us a clue. This is the quadratic formula. X equals all of that. And yes, you are expected to have this formula memorized. But over the years of teaching this course, the majority of students have no issues memorizing it, mainly because they'll be using it quite a bit. And the more often you use it, the more it will stick with you. So, what is the quadratic formula for? Well, this variable, it's no coincidence that it's an x. So what do you think the quadratic formula is meant to help us find? The x-intercepts. Now, you're probably wondering, but didn't we already do this? Didn't we solve quadratic equations by factoring, which then told us what the x-intercepts are? It sure did. Now, the problem with this with what we've been doing before, was that I had to handpick numbers to make them look pretty. Now, remember this question back in 6b, where I said, we're stuck. I can't factor this anymore, because I need to find two numbers that multiply to give me whatever 6 times 1155 is, but at the same time must add to give me 13. And remember how we stopped? So, quadratic formula to the rescue. The quadratic formula is used essentially when all factoring methods fail. When all factoring methods fail. In other words, this is a fail-safe for finding the x-intercepts, or the value of x. So, but then what does A, B, and C represent? Well, A, B, and C, A just represents the coefficient, the very first value, the coefficient of, the leading coefficient, of our quadratic equation. Okay? And what does A, B, and C represent? Well, as you can clearly see, B just represents the coefficient of the middle term. Okay? Now notice how it's a negative B. Yeah, meaning whatever B value is here, including the sign in front, we need to switch it. So for example, if that's a plus 5, that would be a negative 5, and so forth. Okay? And of course, C is just our constant. Okay? So, does this mean that I can use the quadratic formula to find all x-intercepts? Yes, it does. Yeah, so, why should I care? Well, I already answered that. To find x-intercepts. Okay? To find x-intercepts. Now, I'm sure you have lots of questions, but don't worry, they'll be answered very shortly. Now, I'm not going to go through the proof of the quadratic formula. If you are interested, in fact, this might be a challenge for you. See if you can complete the square with those three terms. If you want, you don't have to, but this is just a proof of where the quadratic formula came from. But the purpose of this lesson is simply on how to use it. Okay? So, for example, let's say we have this equation. Okay? Now, I'm going to try to factor it first. That should be my first instinct. So I need two numbers that will multiply to give me negative 8. But at the same time, must add to give me negative 3. Let's see. 4 times 2? No. 8 times 1? No. That's it, isn't it? There's nothing else. 8, 1, 4, 2 are clearly not going to give me a negative 3. So Since I cannot factor, I'm going to use the quadratic formula. So my a value is 2, my b value is negative 3, and my c value is negative 4. And I'm going to plug all those numbers into my formula, x equals negative b plus minus. I'll explain what the plus minus means in a second. Square root of b squared minus 4ac divided by 2a. So what is my b value? Negative 3. So notice how my b is replaced with a negative 3. Okay, now I still left a negative there, and you'll see why in a second. Well, it's because it's part of the formula. Plus minus square root of a b squared, negative 3 squared, minus 4a. Sorry, let's backtrack a little bit here. B is negative 3, negative 3. Okay? What is minus 4a? What is my a value? Let's scroll back up again. My a value is 2. A value is 2. A value is 2. Times c. What is my c value? Negative 4. Negative 4. Negative 4. Negative 4. So I'm just plugging in. Divided by 2 times 2. Well, where did that 2 come from? Well, it was my a value. Okay? Now, from here, I just got to solve. So negative 3 squared is 9. 9 minus 4 times 2 times negative 4. Now be careful. Bedmass. Do not forget bedmass. Bedmass means that I need to take care of the multiplication here first. Okay? So I cannot go negative 3 squared 9 minus 4 is 5. That is not correct. I have to take care of these 3 terms first. 1, 2, 3. So negative 4 times 2 is negative 8. Negative 8 times negative 4 is 32. Okay? Positive 32. So I have 9 plus 32 is 41. Okay? Square root of 41. Now, what's there? So I'm going to copy this down. So negative 3 will make it a positive 3. 2 times 2 is 4. Now, the plus and minus means there are 2 answers. In one case we add, and in the other case we subtract. That's why there is a plus sign and a minus sign. In one case we add, in the other case we subtract. Okay? And why do you think we do that? Well, simply because we want to look at the number of x-intercepts. In this case we have 2. So we plug this into the calculator. For one x-intercept we'll get 2.35, which means on our graph one x-intercept would be 2.350 and the other one would be negative 0.850. Okay? And those are the x-intercepts. Now clearly there's no way for you to factor in order to get those numbers. So let's verify our answers. Let's verify our answers. So I'm going to go to Desmos. Let's scroll to the top. What was the equation? 2x squared. So y equals 2x squared minus 3x minus 4. Okay? So 2x squared minus 3x minus 4. 2x squared minus 3x minus 4. So let's scroll down. X-intercepts are 2.350, 2.350, and negative 0.850. Negative 0.850. Okay? And there you go. Now, you should be able to handle a lot of these questions, okay? But there's one thing I want to bring to your attention, because I can hear it already. Some of you are probably still asking, why? Does that mean if I just memorize a quadratic formula, I can factor anything? There's no need to factor, because I can just find the x-intercepts that way? Not necessarily, okay? I mean, technically you're right. Technically you're right. So, let's use a simple example. So y equals x squared plus 5x plus 6. Now, traditionally, if I were to ask you, hey, what are the x-intercepts? What are the x-intercepts? You would say, okay, x-intercepts. That means I need to factor. So I need 2 numbers that will multiply to give me 6, but at the same time must add to give me 5. And what are those 2 numbers? 3 and 2. 3 and 2. Now this is indeed simple factoring because there's a 1 in front. So then I'm done. Okay. And then from here, well, what are the x-intercepts? Well, I know that this is going to be x equals to negative 2 because x plus 2 equals to 0, solve for x. Same thing here. X plus 3 equals to 0, solve for x. X equals to negative 3. So those will be my x-intercept if I were to draw them. Negative 3, negative 2, and that would be my parabola. You can check on decimals as well. So if I were to use the quadratic formula on this, would I get the same answer? I sure would, because my a value is 1, my b value is positive 5, b, this is a, and my c value is 6. So let's plug it in and see what happens. I'm going to use pink. So x equals to negative b, so I'm going to write the formula down, negative b plus minus square root of b squared minus 4ac divided by 2a. So let's plug the numbers in. Negative b. So my b value is 5. So it's negative 5 plus minus square root of b squared. So b was 5, right? B was 5. So 5 squared is 25. 25 minus 4. And what was my a value? 1. My a value is 1. And my c value was 6. C value is 6. Divide all that by 2 times a. 1. Okay. And what do we get? Negative 5 plus minus 25 minus 4 times 1 is 4 times 6 is 24 divided by 2 times 1 is 2. Okay. And then equals to negative 5 plus minus square root of 1 divided by 2. So I get equals negative 5 plus minus square root of 1 is just 1 divided by 2, which means my two answers are x equals to negative 5 plus 1 divided by 2 and x equals to negative 5 minus 1 divided by 2, which means negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. Negative 5 minus 1 is negative 6. Negative 6 divided by 2 is negative 3. Are these two the exact same x-intercepts as these two? Yes, they are. So, yes, they both will tell you the x-intercepts. But, this is factoring is clearly more efficient than finding the x using the quadratic formula. Okay, but when you have no choice and you can't factor, you have to use the quadratic formula. In this case, I just chose an example where we were able to factor just to show you that both will work. Okay, now, word of caution. For those of you who got in the habit of looking at the factors and changing the signs, I warned you to always keep in mind that it's not just switching the signs. What you're doing is solving for x plus 2 equals to 0. Okay? Because if you keep convincing yourself you're just switching the signs, you're going to get confused. When you find the x-intercept here, and it's negative 2, it says x equals to negative 2, that is the x-intercept. You do not switch the signs. Okay? So this will give you your x-intercepts directly. Gives you your x-intercepts directly. Whereas, in this case, in the factored form, you still have to solve each factor, setting them equals to 0 to find out what the x-intercepts are. Okay? Alright, so practice through these questions. It's the same thing for each one. Just identify your A, B, and your C, and then solve for the x-intercept. Okay, and check your answers on decimals. Okay? Alright, take care.